This revision video is for AQA M1. The topic is Newton's laws of motion in 2 dimensions, and we're looking at question 5 from January 2010. So let's just start by looking at the question. The constant forces F1, 8i plus 12j newtons, and F2, 4i minus 4j newtons act on a particle. No other forces act on the particle. Firstly, we're asked to find the resultant force acting on the particle. Given that the mass of the particle is 4 kilograms, show that the acceleration of the particle is 3i plus 2j. At time t seconds, the velocity of the particle is v meters per second. When t equals 20, the velocity is 40i plus 32j. Show that when t equals 0, the velocity is negative 20 minus 8j. In part 2, we're asked to write down an expression for v at time t. And in part 3, find the times when the speed of the particle is 8 meters per second. So let's go back to the beginning and make a start. So we have this particle and it's got 2 forces acting on it. So one in this direction, F1 roughly, and another one sort of pulling it in this sort of direction. That's really, the diagram isn't particularly essential in this case, but that's what's happening. So no other forces acting on the particle. So in part A, we're asked to find the resultant force. So all we actually have to do is to take those 2 forces, F1 and F2, and add them together. So that's going to be 8i plus 12j plus 4i minus 4j. So we add the I components and the j components. We bring them together, so we end up with 12i plus 8j. And that will be in newtons. In part B then, it says, given that the mass of the particle is 4 kilograms, show that the acceleration is 3i plus 2j. So we're using Newton's laws of motion in 2 dimensions. So remember, it's the resultant force is equal to mass times acceleration. We now know that the resultant force is 12i plus 8j. So that will be equal to the mass times the acceleration. The mass was 4. So dividing through by 4, that tells us that the acceleration is 3i plus 2j. And that would be meters per second squared. So we've managed to show that. So let's move on to part C. So at time t seconds, the velocity of the particle is v meters per second. So when t equals 20, we know that the velocity is 40i plus 32j. And we're asked to find the velocity when t equals 0. In other words, we're really being asked to find the initial velocity. So we know that t equals 20. We have the velocity is 40i plus 32j, and the acceleration, if you remember from what we did just before, we worked out to be 3i plus 2j. And so basically what we want to do is we want to find u. So we're using v equals u plus at. So, and we can substitute that in. So v is 40i plus 32j equals u, which is what we're trying to find, plus a, 3i plus 2j times t, which is 20. So we should be able to do that now. So we would have 40i there and 60 over here, so that's going to be minus 20. rearranging the sides, and 32j on the left 40j here, but we've moved the u over, so that's going to be minus 8j. So that now is our initial velocity, and the units of course would be meters per second. The next part of the question we could probably do here. So this was part 1. If we just look at part 2 says write down an expression for v at a time t. So using v equals u plus at, we know that we now know that the initial velocity is u we now know is minus 20I minus 8j. So v equals u plus at, so a is 3I plus 2j, and we multiply that by t. So that, if I put that, that's u plus at. So we have now got an expression for v at time t. And in part 3, what we're trying to do now is we're trying to work out the times when the speed is 8 meters per second. So just let's remind ourselves, we said that v was equal to minus 20I minus 8j, so that was your initial velocity, plus at. And the best thing to do with that now is to bring the I and the j components together, because what we're being asked to do is to find the times when the speed is 8. So if we could bring the components, the I components together, then we would have 3t, I'll put the positive bit first, minus 20I, and bringing the j components, we've got 2t minus 8 j in the j direction. And so basically you've got a situation where we know the velocity in this direction and we know the velocity in this direction, the i's and the j's. So this is 3t minus 20 and this is 2t minus 8. This is only a little diagram to help us, so it doesn't need to be too accurate. What we are told is that the speed is 8. And remember, so this is I and j, so they are at a right angle. So we can actually just use Pythagoras Theorem. So using Pythagoras Theorem now, that means that 3t minus 20 all squared plus 2t minus 8 all squared must be equal to 8 squared. So we need to multiply out our brackets, factorize if possible, if not use the quadratic formula. When we do this, we'll get a 9t squared from there and a 4t squared from there, so that's going to be 13t squared altogether. We'll get a minus 120t there, and we'll get a minus 32t there, so that's going to be minus 152t. So just check that you can get those. You're going to have a plus 400 here, plus 64 here, but we've also got a plus 64 here, so that 64 and that 64 will cancel out, and we'll have plus 400. Now, unfortunately, it doesn't factorize, and so we do have to use a quadratic formula. So doing that, we end up with t equals 152 plus or minus the square root of b squared, which would be 152 squared, minus 4 times 13 times 400, and I'll bring my line across, and that will all be over 2a, which is 2 times 13, which is 26. And if you work that out, and you can use your calculators, then it gives us two answers, either t equals 4 or t equals 7.69. So either 4 seconds or 7.69 seconds to 3 significant figures. So quite a bit of work there. I just need to go through and check that all your calculations are correct. So let's just go back to the beginning and have a look and see how the marks were awarded. So just starting then, the first 2 marks, well, the first 2 marks there was a method mark for knowing that you just needed to add these 2 forces, and an accuracy mark for doing that correctly. And similar sort of thing here, a method mark for using Newton's second law with your resultant force, and an accuracy mark for getting your acceleration. There was a mark here, a method mark for using v equals u plus at with your values of v and a and t correctly, and another mark for putting in your acceleration here, so independent of method, and then an accuracy mark for getting your initial velocity and showing that it was negative 20i minus 8j. There was a B mark, an independent of method mark, for writing down an expression for v in terms of t, and then it was a method mark for bringing your components together, so your i's and your j's, realizing that that was what you were needing to do, and also a method mark then for realizing that that also meant that using your triangle over here that you needed to use Pythagoras. An accuracy mark for getting as far, in fact 2 accuracy marks for getting to 13t squared minus 152t plus 400, which would take probably more than 1 line if you were writing it out. A method mark for using your quadratic formula, and then an accuracy mark for getting your 2 times. So 14 marks in total for the question. So don't forget that if you do want to access further revision videos, then you can go to the website, FMSP website, and follow the link to online revision.